Hi, my name is Al Wolf. I'm here today to talk about a fractal, one known as the Mandelbrot Set. I got into this many years ago. My background is as a math major, and I've been into computer science and programming and developing software, kind of was my career, but I got interested in fractals and this particular fractal some time ago, and have spent hours and hours exploring different parts of it. I don't know if this image may be familiar to some of you. This is a picture of the Mandelbrot set. Actually, it's the area in black that formally is the Mandelbrot set. The other colorful stuff surrounding it you could view as window dressing, but in fact that's where a lot of the interest and the beauty of what I'm going to show you is in those colorful images. Now, I've done a fair amount of traveling around the world, seen a lot of incredible things, but I kind of count this particular thing among the very top things that I've seen in the world. And you can do it all sitting in front of your computer and explore the Mandelbrot set. Now, it has seemed to me that this image resembles a sitting Buddha, right? And especially if you rotate it 90 degrees, right, it looks to me like a sitting Buddha. You can clearly see the body, the head, and a pointed crown up at the top. Okay? And maybe it was recognizing or seeing this Buddha image that inspired me to come up with an interpretation of the Mandelbrot set that gives it kind of spiritual meaning as well. Right, so my whole approach here is to use the set in a metaphorical kind of way to explore the relationship between the Buddha and the universe, or what's more maybe familiar to much of my audience, between God and the universe, right? The relationship between God and the universe in a metaphoric way. And the area that you see in black, that's God. The rest of what's inside of the circle there represents the universe. Okay? And right, it's easy to modify the interpretation a little bit to make it the relationship between the force, if you're a Trekkie, and the universe, right? Or in a non-theistic kind of way, maybe between nature and the universe, right? Or love kind of as a cosmic ideal, the relationship between love and the universe. And maybe if you're a little bit like me, you view all those things as different aspects of the same thing. All of it works. For the rest of my presentation, I'm going to talk about it in terms of God and the universe, okay, and that relationship. Okay, so I'm going to now very quickly switch over to some fractal exploration software. And as we do that, just a few things to keep in mind or to look for. One is the deep zooming that we're going to do, where we look deeper and deeper into the set. You're going to see that Buddha image crop up over and over again. And also take note that of the bands that kind of form the colorful images that surround the set. Okay, so just give me a moment here and we're going to switch over. Before we even go any further, let me make the first observation in using my metaphor, which is to say that it's clear that God dominates the universe. It's the most central, obvious thing in the image. So, we can say right off the bat that God dominates the universe. And you can also see here some of the outer bands of the colorful bands that surround the Buddha image. And, the bands go on infinitely deep. Hey, so now I'm going to begin to do a little bit of exploring. It's pretty easy to do with the software. Basically, you can move the image around and start to zoom in. So that's what I'm going to do, a bit of zooming. Maybe I'll find some point over in this area. Okay, this is starting to look good. Now, you should start to see some little Buddha images starting to appear, like there's one up here. This is one right about at this point. Is that showing up? Yep. So let's zoom in on that one a bit. Okay, and there's another little one down there as well. There are many other very interesting things to see besides the Buddha images, but for purposes of this talk, I'm going to emphasize looking at some of the other Buddha images. So, this is, again, a part of God, and we can now say that God not only dominates the universe, but that his presence is seen and felt even in the tiniest details all over the universe. So these little images pop up all over the place. Okay? And maybe we'll pick another tiny one over here and zoom in on that. Okay, that doesn't look bad, and I'm going to do something here to change the coloring, the way this is colored in. Maybe here. Well, that looks pretty nice. So you start to see, you get these very interesting, complex pictures of the set. And you can do, the software lets you do interesting things like rotating through the colors so that you get a motion kind of effect. I'll show you that. We cycle colors. I kind of like cycling backwards a little bit. Try to move this out of the way. All right, so you get these very interesting, colorful, psychedelic even kinds of effects from the software. Now, I also want to point out at this point, this zooming that we're doing, right, focuses in on a smaller and smaller area, but with each zoom, we're also doubling in size, right? If you remember what the original image looked like, and if we zoomed in something like 93 times, that original image would fill the entire real universe. That's how big the zooming gets to be when you're doubling over and over again in size 93 times. You get something that would fill the entire real universe. And that's not terribly difficult to do. I've zoomed in well over the 93 times, a couple of hundred times even, and so you're getting you know, if you magnified the original image to that degree, you'd have something that would fill a universe of universes, put it that way. Another way to think about that, and one that I think is very interesting, is if you do the kind of thing that I just did, right, which is zooming in, you know, exploring a little bit randomly here and there, right, you are almost surely guaranteed to be exploring a part of the universe that nobody else has ever been to before or ever will be again. It's just that big, and the only caveat that I have to say about that is that since I'm being filmed here, you know, somebody could follow the exact steps that I've gone through and come back to this same place. But if you're doing things a little bit randomly exploring, you're sure to be at a place that nobody has ever visited before. So I think that's kind of neat. And furthermore, if in all your zooming, as I have done, you land on a Buddha image, then we can say that you have found your own unique path to God, right? I'm claiming that the image you're seeing here, nobody else has ever been to before. So by getting to this spot and finding this magnified but tiny little God image, right, that I've found a unique path to God. So that's something that anybody could do. Okay, so that was just a little bit to give you a feel for exploring the universe, and at this point now I'm going to switch back to the main body of the presentation. Okay, so you know, I started talking about fractals and I haven't really said what the heck a fractal is. So there's a lot of varying definitions, but the key thing in all the definitions is it's an object that shows some self-similarity when you view it at different scales. So with what we just saw, for example, you know, we saw that great big Buddha image in the original image, and then as we scaled down and looked at little pieces, you saw other things, Buddha images that looked, if not exactly the same, very, very similar. For purely mathematical fractals like this one, there's always some kind of recursive or iterative process involved in its creation. Fractals also occur in nature, or fractal-like things. So if you look at the fern image on the left and you look at the branches off of the main stem, right, and then focus in on one of the branches, you'll see that its structure mimics the main structure off the main stem. And you can even start to detect that a little bit one level down. If you look at one of the sub-branches off the main branch, you'll find it also has a similar structure. And with the image on the right, I wouldn't have recognized that as a fern, but it is in the fern family. And that curlicue kind of structure, right, exists at multiple levels. The overall design, you can see it, you know, with the curlicues kind of one level down, and even if you look carefully at a further level than that, it replicates the same kind of structure. Now, I don't think the biologists have proven this yet, but I feel very confident in predicting that there is some part of the plant's DNA that is used in a repetitive or recursive kind of process to create this kind of structure at multiple levels. And if this were a mathematical fractal, this pattern would continue infinitely deep at deeper and deeper levels. You'd continue to see the same thing. But, you know, biology, physical things have restrictions on cell sizes, etc. Okay? So here it is again, the original image. And now I'm just going to take you through a few different images that I have captured in my exploration of the Mandelbrot set, just to give you a further feel for what's there. Okay? So here you're looking at a first set of images. The Buddha image occurs over and over again. Okay? Some images have, are pretty similar, pretty simple in structure, especially out towards the crown. If you remember that, you get some relatively simple images. Other places you find things that are sort of grotesque looking, like this. A lot of these pictures remind me of some kind of strange creatures or bugs holding hands or grouped together, or very strange looking appendages attached to them. So you get some things beautiful, some things rather grotesque. Here are some images that I find, very attractive, having very nice symmetries. And all of this is just from exploring and seeing different parts of the Mandelbrot set. Okay. Now I'm going to start to talk about how all of this is built. And we're going to get into a little bit of mathematics. I hope this doesn't get to be too difficult. Tried to simplify it. Okay, first of all, we see that the Mandelbrot set is made from the universe in layers. And here I'm showing the first 5 layers only. Okay. As you add layers, now going up to 10 layers, you can see the Mandelbrot set that we looked at earlier starting to take shape. Right? By the time you get to 20 layers, now it's really getting clear cut to look like the Mandelbrot set. So in terms of our spiritual interpretation, right, now we can say that there's kind of a dichotomy here, right? Not only does God dominate the universe, but the universe tends to perfect or complete God, right? As we add layers and layers in here, we get a clearer and clearer image of God. But if we view this from the point of view of human exploration, right, we can probe deeper and deeper and deeper and get closer and closer to our understanding of God, but it can never be complete. There are always more layers to add in that make our understanding of God even better. Now, one other thing I want to point out here is that all of these layers that you see, you can really only clearly see the outermost ones, but all layers are completely continuous. That is, if you started back here, and this is the point where all the infinite layers come together at this point all the way back here. But if you started here and began to trace your way around a layer, like maybe this orange one, you'd come here, you'd round the corner up here, and eventually come back to where you started from. And that's true not only of these outer layers, but all layers. And again, the number of layers are infinite. So what that kind of speaks to is that the universe is very much interconnected. It's interconnected in ways that are not at all obvious. If you remember when we did our exploration, you saw individual Buddhas, you saw different kinds of things, and they're all interconnected because the layers are interconnected. And the same thing is true about the Buddha images themselves. And I think fairly recently the mathematicians have formally proven it. I kind of knew it all along, but all of the Buddhas themselves are interconnected. So even though we saw them on the big scale, you see them in tiny places all over the universe, they are all interconnected. So in reality, even though we see all these multiple images, they're all connected, so there really is one God. Different aspects of them, but only one, all interconnected. The software that I use default starts with 400 layers, and that's usually quite a bit to do a lot of exploring, but if you go deep in, sometimes you want to add additional layers, and the software lets you do that. You can have millions of layers. Okay. All right, now we're going to start to get more into the math a little bit. Here's where it all is on the XY scale. Everything of interest is inside of this circle at the centered at the origin with a radius of 2. Okay? And just sort of make special note of this point up here, the 2, 2 point outside of the circle. I'm going to do something further with that. And this point 0.5 inside of, that's clearly inside of the Mandelbrot set. And I'll show you some things that relate to that. Now, okay, as I start to get into the math a little bit, you don't have to understand the details of the math involved, but a couple of things that you should kind of focus on. Okay? One is when you're looking at a screen image, screen images are made up of pixels, tiny little dots of light. No matter what what image you're looking at, each pixel represents a different XY coordinate. Right? Now, when you zoom way in, even adjacent pixels, you might have to go out 50 decimal places to see that they're different from one another. But nonetheless, every pixel on the screen represents a different XY point. Right? So the calculations that I'm going to show you are repeated for every pixel on the screen. Right? So the image of some section of the Mandelbrot set is built up kind of a pixel at a time, and the basic nature of the calculations will be to tell us which layer number that pixel belongs to. And then once you have the layer number of all the pixels, then you can assign colors to the layers in a whole different variety of ways. Okay. So again, the calculations now, the AB represents some point, some pixel, and its XY coordinates, right? And now the main idea that you need to understand, don't pay too much attention to exactly how the calculation is done, but from that pixel we're going to generate an infinite series, right? You start out with an initial value, right? Plug those numbers into this formula to get the next value, right? That gives you a new value for X and Y. You plug that new value back into the formula and you get another new value for X and Y. And you can keep on doing that infinitely. So you're creating here an infinite series, basically, right? By doing this recursive process of you have a starting point, plug numbers in, get new values out, plug those into the formula, you get a new set, and you can continue to do that infinitely. Now, when you do that, one of a number of radically different things happens with that generated series. Okay? And I'm going to show you some of those things. Okay? Now this is just, if in your leisure when you look at the video, you want to get a better understanding of how the arithmetic is done, you can come back and look at this. But it's just showing for this point that I showed you that was clearly inside the Mandelbrot set. how the first few values in the infinite series get calculated. Okay. Here's a spreadsheet showing the series calculation for the point 0, 1/2, which is inside the main Buddha. Note that the numbers start out scattered but converge to a single value as the series progresses. In fact, it continues this way for all of the infinite series. The critical factor is that the series remains bounded forever. Here we observe convergence to a single value. In other places within the set, the series rotates among 2 or more values, but remains bounded throughout. The generation of a bounded series is the official definition of the Mandelbrot set, always leading to a Buddha image. So, we can say that the bounded infinite series always leads to God. The convergence to a single value or to a rotation of values represents stability or peace, continuing without end. Summarizing, only through God can we reach the infinite. The path to God is one of eternal peace. By way of contrast, here is the beginning of the infinite series for the point 2, 2, not just outside the Mandelbrot set, but outside the main circle. Here the series is clearly unbounded, quickly generating gargantuan numbers, roughly doubling the number of digits with each successive term. The capital E notation effectively indicates the number of digits. All points outside the main circle behave like this. So this is total havoc or chaos. Next, we'll look at the series run for points within the bands. These series start out bounded, but ultimately break out, leading to the chaotic scenario. Really, the ones that are the most interesting are to look at how that series evolves for points that are within the layers, right? We looked at one that was inside the black area, the Mandelbrot set. We looked at one that was outside the circle. Now we're going to look at a few that are in the layers. And here these 3 points, A, B, and C, are all in the outermost layers. Right? So let's look at what the series run looks like for those 3 points. Right? Well, you can see they start out bounded, and then very quickly they get to a point where they're generating these huge numbers. Now, there's a very simple test, right, that lets you know whether the series is going to go berserk, is going to generate these huge numbers. Right? And I marked that point with this red triple X. That's the point at which you can tell that you're going to these gigantic numbers and never going to come back again. Right? And actually the test is if the series generates any point that is outside of that original circle that we saw, that's the sign that the series is about to go crazy. Okay? So now we're kind of at a point where we can put it all together, right, and say this is how the layer number gets calculated, right? You count how many iterations happen before you get to that point where you know it's going to be going out of bounds, you know, with these huge numbers. And that number of terms in the series before it goes crazy, right, that becomes the layer number. So you repeat that for every pixel on the screen, do the calculations. For every pixel, then you can assign a layer number. Once you have the layer number, then there are a variety of different kinds of coloring algorithms to complete the image. In some places, you want colors where each adjacent layer is a much different color. In other parts, you want a coloring method where many layers, consecutive layers, are the same exact color, or maybe a color that changes just a little bit from one layer to the next. Okay? One more, okay, that we'll take a look at, right? Looking a little bit deeper into the layers, and this is a layer somewhere out in the 60s or so that we're going to look at the series run for it. Okay? And, you know, without spending a whole lot of time on this, you may see that as you go out, it looks like the numbers start to bounce back and forth between 2 points, you know, this 0.59 minus 0.59 number and the 0.41, and that repeats going back and forth. Right? And I'm going to now, on the next slide, I will show you graphically a graph of the first 10 items in the series, some 10 points from the middle of the series, and another 10 just before it goes crazy out of bounds when it gets up into the 60s. Okay, so here's that picture, right? The first 10, you see it going back and forth, but, you know, within a fairly narrow range. By the time you get to the middle of that 60 some odd terms, it looks like it's really tightening up quite a bit. And at that point, you might say to yourself, oh, it looks like it's going to stay that way forever and ever. Right? But when you get, you know, out towards the 60th term or so, all of a sudden it all kind of starts to fall apart. And in the next iteration, you know, it's going to go bananas, going to go to those huge high numbers. So that's what, you know, what it looks like for a layer like level, you know, in a layer in the 60s or so. So this to me is another kind of interesting phenomena when you consider, for example, maybe going into layer 1,000 or 1,000,000. What you're going to see there is, in the series, is something that looks very predictable, and it stays that way, it seems like, forever and ever and ever. And then when you get out near layer 1,000 or layer or term 1,000 or the millionth term, you know, that predictable cycle suddenly falls apart and you generate these huge, gigantic numbers. So there's maybe kind of a message to humanity in all of that phenomenon, right? Which is kind of to beware of things that look like they're predictable and in a predictable cycle, right? It's not inconceivable that they're about to totally fall apart. So you could apply that idea to environmental issues, economic issues, a variety of ways. And another kind of way to look at it is, you know, if you were at a point that's either infinite inside the Mandelbrot set or at a very high layer number, and you moved it just a little bit, you know, all of a sudden you could be in a whole different space that's about to create chaos at any moment. Okay. That pretty much concludes my talk. Right? I will just leave this slide up there as kind of a summary for you to read of the main insights that I gather in my spiritual exploration of the Mandelbrot set. So I'm not going to read through these, but you're welcome to view them. And then thank you all very much for your kind attention.